questions slow me down. So a rate of solubility is the speed that a solute dissolves in the solvent. How fast, right? You want to dissolve quickly your sugar into your tea. Well, what can you do? You can stir it, heat it, or, if it's a sugar cube, you could crush that cube up. Stir, heat, crush, those things will make solids and liquids dissolve faster. Pressure will make something dissolve faster and better only if it's a gas, like the carbon dioxide bubbles in your soda. So what is solubility in general? Well, that's not just how fast, that's how much, the amount of solute that dissolves in the solvent. Okay. And what affects that? Well, the types of substances. Some things dissolve better than others. Pressure, right? If it's a gas, that's why you have the cap on your soda where it keeps the pressure in, keeps those bubbles in your soda. And we're going to focus on temperature. Temperature can not just affect how fast it dissolves, but it can affect how much dissolves. Okay, so again, for solids and liquids, the higher the temperature, the more that you can dissolve. If I want to make sweet tea, I'm going to heat that tea up. For gases, the higher the temperature, the less that dissolves. Right? That's why your soda goes flat faster in the summer, or if it's sitting in some warm place, because gases like it to be cold. Okay, so we're going to take a look. This is similar to your table G, not exactly like your table G, but similar. This is an older version of table G. And you can see all these substances that go up, these are solids and liquids. The substances that go down, those are gases. Because high temperatures, gases don't like to dissolve very much in warm things. Okay, so let's take a look at some of the questions they can ask. They could ask, okay, at temperature 10 degrees, which of these solutes is the most soluble? You can go all the way to the top, Ki. They could also ask, at 90 degrees, which is the least soluble? The least soluble would be right here, which is Ce2SO43. And again, they have different chemicals on this table G than your table G, but I'm just giving you the general idea of how to read a table G in general. Okay, so that's either least or most. Let's look at some other more specific questions. They could ask, at 20 degrees, if NaNO3 is dissolved in 100 grams of water, how much can dissolve? Well, it's always 100 grams of water you're dissolving it in. This chart assumes you're using water as your solvent and 100 grams always. So let's focus on what the problem's really asking. Find 20 degrees and NaNO3. So 20 degrees, NaNO3, right here. And then let's go over and read how much, how many grams. And that's about 88. Now, if you thought 87 or 89 or 86, anywhere in that range, but I would say around 88. So let's go through. Try one. Go find the temperature and the substance and figure out how many grams will dissolve. And again, if you have a question, just unmute and ask it out loud. Okay, so hopefully you found 70 degrees. And then you have to find whatever salt or substance they're asking for, NH4Cl. And in this case, this is really exactly on the line at 60. Okay, so 60 grams will dissolve in 100 grams of water. Again, it's always 100 grams of water. Don't let that throw you. Next. They could ask about different kinds of solutions. You can make something that's very dilute or weak, unsaturated, where you could still dissolve more if you had to. Saturated is completely full, exactly full. And supersaturated, where you added too much. So again, unsaturated, it'll be under the curve or under the line. Saturated will be exactly on the line or curve. And supersaturated will be more, will be above, like Superman is above us. Okay, so let's try these questions. At 80 degrees, 60 grams of KCl is dissolved. Again, it's always 100 grams of water, so you can kind of ignore that. Find 80 degrees and KCl. Let's do that first. Don't do the 60 grams yet. 80 degrees KCl. Okay, so 80 KCl. KCl is at 50, but they added 60. Notice I'm going to put my finger here, so to speak, right here. It's above the line. It's above that point, that spot. So they made a supersaturated solution. Right? So normally it can only hold 50, but they made a supersaturated because it's above what it can normally be holding. Try one yourself. Again, find the temperature and the substance, then compare the grams. Always do the temperature and the substance first. Okay, so hopefully you found 20 degrees. This one's a little tricky. KNO3, 20 degrees is right about here. So it's a little above 30. But they added 30. So I'm going to put my finger here. That's what they added. Right? I'm comparing what they added, 30, to what could be added. So notice they added 30, which is below the curve. They made an unsaturated solution. And try another. This is about as tough as it gets. Find the temperature and the substance first. So 45 degrees, NaNO3, can usually hold 110. Oh, and in this case, that's what they added. So if I find theirs, I'll put my finger exactly at 110, and that's the same as the line. It's right on the line. So they made a saturated solution. Saturated. And I think this is maybe our last one. Let's see. Find the temperature and the substance, then compare. Okay. So found 90. NH4Cl's here. They added 60. Let's see where 60 is. 10, 20, 30, 40, 50, 60. Okay, so I'm going to put my finger here because that's what they added, 60. Notice my finger is below the line at that temperature. They made an unsaturated solution. So it's not that the line is above me. It's what they made is below what normally can be, right? These lines and curves are the normal, are the saturation points. So they made it below unsaturated. Okay, so again, those are the 3 kinds of questions they can ask. I'll run through them maybe one more time here. Let me find my generic graph and go back. Okay, so again, they can give you a temperature and say, hey, what's the least soluble? Or what's the most soluble? They could give you a temperature and ask you how much dissolves. So 90 degrees NH4Cl would be 70 grams. Or they can ask what kind of solution was made at a certain temperature. So they could say, let's say 80 degrees KCl can normally hold 50. But let's say they added 60 instead. They added 60, that's above the curve, above the line. So they made supersaturated. So again, they can ask you least, most. They can ask you at a temperature how much, or they can ask you to compare how much can normally be held to a supersaturated, saturated, or undersaturated solution.